If the viewers of this channel are asked what is the largest planet in the solar system, most, without much hesitation, will immediately answer Jupiter, of course, and they will be absolutely right. But what about dwarf planets? Which one is the largest? Here, I'm sure it will take some time, but still many will answer quickly, and most importantly, right, Pluto. But further, to name the second and third largest dwarf planets of our system, it takes even more time. And not everyone will be able to list, without the help of Wikipedia, at least a few candidates for dwarf planets. But in fact, there are quite a few candidates for dwarf planets, and one of the largest such objects that begs to try on the status is Quaoar. Yes, you heard right, I did not make a reservation. Quaoar was discovered in 2002 by the famous group of astronomers Mike Brown. They discovered almost all dwarf planets, except Pluto and Ceres, some great power from the myths of the Indian people of Tongva. Therefore, the quasar has absolutely nothing to do with it. Why did you choose this name? The Palm Observatory, where the object was observed for the first time, is located in Southern California on the territory of this people. That's how their part was called that. Compared to other Kuiper Belt objects, Quaoar may not look too remarkable, but it is an important part of astronomical history. Quaoar became the first large object beyond the orbit of Neptune to be discovered after Pluto. His find is an omen of the discovery, in the next 3 years, of Sedna, Oricus, Haumea, Makemake and a number of other bodies. In turn, this has led to a number of important events, including a revision of Pluto's status, and the current search for Planet X. Quaoar is a trans-Neptunian object. These are celestial bodies that revolve in orbit around the Sun, and whose average distance to the star is more than that of Neptune, 30 astronomical units. Quaoar has a maximum distance to the Sun of 44 astronomical units, 44.896 to be precise. It takes 286 Earth years to make a complete revolution around the star. It makes one revolution around its axis in 17.7 days. That is, our day lasts 24 hours, while Quaoar has more than 400 hours. The estimated diameter of Quaoar is 1,260 kilometers and its radius is 544 kilometers. The planetoid follows an almost circular orbit, slightly inclined, but much more planetary than Pluto. Quaoar orbit is unique among large objects, which tend to follow more oblique and more eccentric orbits. With an almost circular orbit, Quaoar is immune to disturbances caused by Neptune, unlike Pluto, which shows it the stability of its orbit. As for the composition of this object, everything is very complicated here. There is very little information. First of all, because Quaoar itself is poorly studied, but thanks to its passage against the background of a distant star, a couple of years ago, it was possible to shed light on some of the mysteries of the celestial body. First of all, no traces of an eclipse were found on the star's light curve, and this imposes both serious restrictions on the size of Quaoar and rather strict upper limits on the density of its atmosphere. After that, an article by a group of American astronomers on the possible atmosphere of Quaoar appeared in the Archive of Electronic Preprints. They looked at 3 gases that can be included in its composition: methane, carbon monoxide and molecular nitrogen. At an average surface temperature of Quaoar, approximately -229 degrees Celsius, nitrogen gas and carbon monoxide, in equilibrium with nitrogen and carbon monoxide on the surface, should form an atmosphere with a pressure of the order of several microbars. The presence of such an atmosphere would lead to a decrease in the brightness of the background star, which was not observed. Thus, the authors of the work excluded the carbon monoxide-nitrogen atmosphere of Quaoar. The situation with methane turned out to be more complicated. Methane sublimates at a higher temperature than nitrogen and carbon monoxide, and the methane atmosphere in equilibrium with methane ice on the surface will have a lower pressure. According to calculations, a methane atmosphere is not excluded from Quaoar. This conclusion is also confirmed by the spectral traces of methane ice on the surface of Quaoar. Well, in the end, in 2007, a satellite was discovered near Quaoar that rotates at a distance of 14,500 kilometers in 12.5 days. He was named Vejvad. This is returning to the mythology of the Tongva people, the son of Quaoar. It has a significantly elongated orbit, and given the unusually high density of the object, the satellite could have formed as a result of the collision of the proto-Quaoar with the more massive body. At the same time, however, Quaoar lost its ice mantle, retaining only a dense core, and a satellite was formed from the emissions from the impact. Why do you think Quaoar has a sufficient mass and size is still walking in candidates for dwarf planets? Because it was discovered in 2002 years earlier than the same Haumea. Let me remind you, any celestial body that revolves around a star with the necessary massiveness to form a sphere, but which is not enough to clear space around itself, is considered a dwarf planet. The mass of the object is also required to help combat compression and bring it into hydrostatic balance. Quaoar undoubtedly has the right to be called a dwarf planet. It is a double object, a density of 2.2 grams per cubic centimeter, a suitable diameter. In general, all this proves that we have a full-fledged dwarf planet. In addition, its mass index for hydrostatic balance is even larger than necessary. So what's the deal? To be honest, I could not find a clear answer to this question. Perhaps he is still a candidate because it is very poorly studied and therefore astronomers doubt those parameters, the dimensions, the mass that are at the moment. And what do you think? Write your options in the comments. By the way, initially, the researchers wanted to send New Horizons to Quaoar after the completion of the mission with Pluto, but NASA stated that this was impossible, since the object was too far from the orbital path of the apparatus. Today there is only such an image of Quaoar from the New Horizons probe. For now, we can only wait for new space missions that will be able to study in detail, not only Quaoar but also many other objects in the Kuiper Belt. More interesting videos about space ahead on my channel. In order not to miss anything, click on the bell under this video. Until new, interesting meetings.